If you don't mind, I'd like to take like a selfie with all you folks so my kids know that I actually do shit on these trips. So if you don't want to be part of my selfie, I may put it online, I don't know, but if you don't want to be part, let's just go like that or something. Don't show any gestures, I have kids. Say cheese or testicle. Sweet. Love you folks. I'm really impressed so many of you guys are here because I struggled to find my room. And then I thought I was in room 4, which was really upsetting because that was closed. I couldn't find the way in. That was stressful. But it seems like you lot are better than me at navigating rooms, so that's cool. Either that or you're really dedicated, or you were here from before and just didn't want to leave because this is air conditioned. It's like IKEA, yeah. The Danish version of IKEA is one conference center. That's all it takes. Right. So I'm going to talk about source generation in .NET. Source generation in .NET is the process of having code that writes code. It's the process of when you build your application, build your code, we can hook in to that process, and we can look at the code that's being built, and we can say, I want to build some more code. I'm going to look at the code that we're having, and I'm going to build more code based on what we're having in there, which can be a powerful tool. It can prevent us from doing lots of reflection in runtime, which may lead to inconvenient runtime bugs. We can prevent the performance hit that we get with reflection. We can prevent the complications of doing ahead-of-time compilation with reflection. And we can get out of a whole bunch of boilerplate code. Instead of writing the same thing over and over again or things that are boring, we can have code generated for us that does the boring stuff. We can use it to enforce rules and conventions, enable our developers to fall in what I learned from Scott Hanselman is called the pit of success. That's where we want our developers to fall into. Like, it makes it hard to make mistakes. Things just happen on their own. So how do we do this? Well, the whole secret is the Roslyn compiler. The Roslyn compiler is the compiler that runs or compiles .NET. It has a couple of extension points where you can hook into that pipeline. And you can look at the code that is being generated or being compiled, and you can see, okay, I want to add some stuff here and get that compiled as well. In its simplest form, it's like this. We have an I incremental generator. The I incremental generator is the interface that Roslyn will look for, it will find it, and it will add it to the pipeline. The interface has one method, has an initialize method, which we use to add stuff to the incremental generator initialization context. Nice little word that just rolls off the tongue. And in this case, we only do one thing. We register a source output. So we can add stuff to our code. In this case, we just add source. This source here. So I generate a static class called hello, has a message that says hello from an incremental generator. My head is too big. And that's all that thing does. We write the code in plain text, which is not super convenient, but this is not where you want to develop your extra code. You do that in a project that you would compile and run and test, and like, right, this is the way I want things to be, and then we just take that and pop it in here. My source has a hint name. I'm not good at taking hints, I've been told. Unfortunately, the compiler is good at it. And the hint name is the name of the output file. The generator project is a .NET Standard 2.0 project. I can still say I want language features of preview, so I can use all the language features that do not require CLR changes. So I can use a bunch of language features that are just compiler specific, but not runtime specific. And I set up some rules. We do not generate output. This code is consumed by Roslyn during compilation. So we do not generate DLLs for this. And we say this is a Roslyn component, and we do not generate a package. We need two libraries, the code analysis C# and the code analysis and analyzers. And we can reference other projects that the generator needs to see. We use the project, the generators, by including a project reference with the output item type of analyzer. So by doing that, I've added that project to my code and say, run this project when you're compiling, or use this when you're compiling. I can choose to emit files. I don't have to. These can be all runtime or all in memory. But sometimes it's useful to get the files themselves as well. They'll end up in the bin object folder, so I can go there and see them. I'm using Writer, so I can see them here in the dependencies, .NET, and source generators. Visual Studio has a similar place where you can actually see the output in your code as well. And here is the hello.g.cs file. So that's a generated code. If I comment this away, so that this code no longer exists, and build my code, this disappears. There's no longer any output. I can comment it back, and if I build the code again, then my source generator comes in. And the sharp ones of you notice that my program CS no longer has a squiggly line. This thing here, hello.message, just works. So let's make something slightly more complicated. Anyone heard of strongly typed identifiers? One. Strongly typed identifier is the concept of, instead of using ints and GUIDs as your identifier for your objects, you use a strongly typed thing. So you have an order ID, you have a product ID type, you have a customer ID type, which makes it a lot harder when you have a method that, instead of having a method that takes 3 different GUIDs to remember which one is which, you have a method that takes an order ID, a product ID, and a customer ID, for instance. And if you want to do this, it requires a bunch of boilerplate, depending on your situation. There are libraries that help you do this, but it's a nice little example of what we can use source generators for. So what I want is I want to have an order ID struct. I want an order ID struct that will function as my order ID, and I want it to be able to input some kind of GUID to it maybe, or use that as my thing. I want to be able to compare it. I need to see what if 2 order IDs are the same. I might have to serialize it, all kinds of stuff that I need some code for. It's not just enough to do a struct order ID and I'm done. You need something more than that. So I have my strong ID generator. Let's just look at what it generates first. It will generate a partial struct. Who knows what the partial keyword does? Okay, most of you. Partial keyword means that I can take a class definition, split in multiple places. I can have in multiple files, and they will be combined into one when I compile. It's useful if you have big classes. You can split them over multiple files, depending on your concern. You might not want to have big files, but it's very useful in this case, because I can now have a partial struct here, and I can generate a partial struct somewhere else with the same name, and those two will be combined into one single struct by the compiler. We have an underlying value, and we have some equals and hash codes, overrides, and try parse, and all kinds of stuff. This is the pipeline for Roslyn. This is an incremental generator. They used to have another generator, which was the first instance of source generation they used, which was not incremental, which was a huge problem because it was a performance drag, massive one. So the incremental generators will look at your code, and only when things that it knows about changes will fire up the rest of your generator. And to do that, we need two things. We need a scout to quickly locate the relevant parts of our code, and we need a filter to make sure that we have the exact parts of the code that we want. And this is our predicate and our transform. Or sorry, this method here, and then we have a filter with a predicate. Now the context I'm getting in gives me what's called a syntax provider. This is a two-step process, sort of like a factory production line. The first part is a scout, which is this one, for attribute with metadata name. That's a function that the Roslyn gives me, saying, find me code. There's lots of seats in here, you don't have to stand. Find me code that has this fully qualified metadata name. And I use a variable here, so I can have it over here, annotations.strongID attribute. So my attribute is this one. Is an attribute that has an underlying type, defaults to system.gwid. So I can, in my programs here, I can say this, or I can do something like that. I can do string underlying. I can say int instead, if I wanted to. But we'll keep it for grid. So find me code, that's a scout. Find the code that has this attribute on it, which is a common pattern with code generation. We'll use attributes because it's really fast for Roslyn to find these. So that's the first scout. Then I have a predicate. That's my filter. Given those attributes, I want only those who is a struct and only those who are partial. The predicate should only look at syntax. That makes it fast. It should not look at semantics. It should not look what the code does. It should just look at the words of the code, the shape of it. These are lambdas, and I keep them as static lambdas, which is a performance thing. Static lambdas will not take closures. They will not allocate any space, and they will not, I cannot accidentally include a variable from outside the lambda into my lambda, so that helps with that. So you want to keep this code as performant as possible, for this will run every single time you compile or build. Now my transform, that's where the magic happens. The transform takes our approved candidates. So we first scout and we find and filter the candidates, and we extract whatever information we need from code generation. So we grab the symbol, which is like Roslyn's semantic representation of our little struct, and then we extract the namespace, testing if it is under the global namespace, the name, the accessibility as a public, private, internal, etc., and the underlying type that we want to have. The result now is that we have a small custom model that contains exactly what we need to generate our code. So in this pipeline says, find all the partial structs with our attribute, extract the metadata from it, and package it into a small model we can use for code generation, and it can be cached by Roslyn. Roslyn needs to know if things changed. So we'll often add a custom comparer. So we have here with the comparer, we have a strong ID equality comparer, which will have the rules that I defined how to compare two of these models. The implementation is not super important, but we want Roslyn to be as effective as possible in finding this list, running the code, seeing if things change, comparing it, and then seeing if we need to do something else. This creates what's called an incremental values provider, which does all the heavy lifting of that part. It will get these lists of candidates, it will compare them, it will cache them, and it will fire off changes if I have something that changes. And then I collect them. So collecting is sort of like going through your workshop and finding all the tools you need, right? So it takes all those things that it found, collects them into one single incremental values provider with an immutable array of my strong ID model. And then I can register the source output. All of this is not code that is run here. This just registers a bunch of functions that Roslyn will call when it needs it. And this static lambda here will take the batch it is given by Roslyn, by all the changed model objects it found. And for each of those, I will call add source. I will use the model name in the file name, because the collect gives me one for each single model type. .strongid.g.gs. The .g is a convention when we generate code, so code files that are generated, we put .g in them to separate these from the others. And we want to make the names unique so that we can have multiples of these and not overwrite each other. And then I call a function called emit. The emit is an arbitrary name, but it's a convention, but you can call it whatever you want, which builds the source code file. This is basically just a bunch of string work. Unlike code I've written, this code is not generated by a tool, but it's generated by me. This just goes through the code that my model looks at what it is, what types it is. Do we need to add this? Do we need to add this? If it's a GUID, we'll do this. If it's not, we'll do some other things. It's not super interesting. My model here, simple little class, takes namespace, accessibility, and the underlying type display. That's what things we want. Now, if I build this code, the squiggly lines in my program CS should disappear. There it goes. I get this file, operator strong ID generator. I have order ID dot strongid dot g dot cs. And this is the code that's generated. My program now, this code is now working, order ID dot new, and this will work just fine. A couple of pitfalls you might have. Make sure you get the right metadata name when you use the for attribute with metadata name. It has to be the fully qualified name. It has to do all the rules that Roslyn has for representing generics, backticks, and all that stuff. If you miss the namespace, it won't find and it won't run. Making the predicate too expensive. Predicate should be short and sweet, syntax only. Don't do anything funky there. You've blown your perf budget. Well, all the semantic word work happens in the transform. Taking a couple of shortcuts here. This code will probably not work if I have multiple attributes because you don't know which one is first. You can test that differently. I can make assumptions because it's my code. You do what you do. Okay. So let's do another one. If you want to debug your generator, you can do that. in two different ways. You can either add a debug attach statement, and then you can attach to, for example, Visual Studio and debug through Visual Studio on your code. Or you can generate tests for this, have unit tests for this that would run your generator, and that will enable you to step through it as well. Let's do an, where did my signal go? Back again. Okay. And it's gone. Oh, you just have to imagine what I'm seeing then. That makes a really poor presentation. Standard trick, plug it out, plug it in again. Well, I have to touch this. Well, oh well. So, for now it works. Okay, here's another one. Say I wanted to not do the whole composition route, set up a bunch of classes, and order what for the dependency injection, the whole service collection thing. What if I wanted to specify on the class what kind of lifetime and what kind of registration this thing should have? So I want a service attribute that says this, the order service, that should always be a singleton. It should be registered as itself. So while this time provider, it should be transient. As an iTime provider type, the clock here. I can hook into this as well. This doesn't lend us so well to find the attribute name, maybe. So we'll have another thing, service registration generator. So now I create a syntax provider. So instead of finding the attribute with the metadata name, I will take a syntax provider, which gives me a bunch of nodes, and I'll say, okay, find only class declarations that have more than one attribute, or more than 0 attributes, sorry. And we're going to skip generic, so we have no type parameters. Make it simpler. So I want the predicate here to be classes with more than 0 attributes. Then I run the transform, and I do a little bit of more work. I want I'll get the symbol where the symbol is not null, and then I'll go through those again and find all the ones that actually have my attribute fully qualified name. So the find with the attribute metadata name, it's an easy scout that's built in, but I can also go down a bit and say, I don't want to use that. I want to inspect all the classes and filter on the ones I want. And again, we build a compact model. Roslyn can keep this. The actual things of the methodology of building that model is not that interesting. I just go through the type, finds the attributes, do some decisions based on that, and I return a small service model that will be small, compact, and super easily cacheable for Roslyn. Now, the first one used collect to get a list of all the different ones I hit. We'll call collect here as well to get all the service models in incremental value provider. But then I will combine these into one. Because in this case, I don't want one file for each of these service collections. I want all of this in one file. So we use combine to take all the ones it found and combine it with the rest of the compilation. then we register some source output, go through all the pairs, emit some code, and then generate a file called generated service collection extensions.g.cs. Again, this is just string manipulation. Nothing much. Build the code. This thing popped up. And this is the code it generates. It will register IE order service as order service. It will register order service as itself as well. So if I ask just for an order service, I can get that from the collection. And it registers iTime provider for clock. The emission of code should always be deterministic. Do not do I/O in it. Do not throw in random this or random that. Do not use date time or anything like that. All my code should be deterministic, including the predicates I have, because that makes sure Roslyn will be able to cache and run only the ones that actually change. So if I change my code, I say actually, I don't want that to be generated like that, then this disappeared. Oh, no, I want it after all. True, there we go. I save my file, and that pops up. How about another one? I want this to be a singleton. There, save my file. It's a singleton. Roslyn runs in the background, compiling my code. It's like, oh, yeah, something changed. Update that one. It should be transient after all. There we go. If I change one class, only that model changes in Roslyn. Only that model is changed in my incremental value provider. Only that model is passed through the collection as changed. But the collection. But the combine will say, oh, one of these have changed. I have to take whatever we had before. It will take the cached versions of all the other ones, and then it will run the emit. So only the code I change will be passed on to Roslyn. A couple of things here. We skipped the open generics because that would require a whole bunch of different code gen. We skip multiple interfaces and stuff like that, but we can make this as complex as we want to. This pattern here is very reusable. Syntax-only pre-filter with the predicate. Semantic attribute match afterwards to narrow it down. Builds tiny immutable model. Roslyn batches it when needed, and we emit source code. Okay, let's do another one. So what I want to do here is I want to have, anyone familiar with the options pattern in .NET? Cool. So we have stuff in our app settings. API key, payments has an IPA key and has timeout in seconds. Super simple stuff. I have payment options with a strongly typed class, which I can use to bind against the options. Now, what if I wanted to have a file that would define this stuff? Some requirements, saying that, hey, okay, payments API key, that's required. Payment timeout seconds should have a default value of 30. This is just a super simple example to show how we can have some kind of random file that is not my code, and we're going to pick that up in the source generator. So in my program CS, I just want to do add payment options. This doesn't work because our code doesn't exist. And we get the required service payment options value, and we can output that. So let's look at the option binding generator. First part here is pretty much the same as we've done. We have a 4-attribute metadata name. We have a fully qualified attribute name. We have a predicate, find all the classes. They should have modifiers that are partials, that should have more than 0 attributes to them. Find me some static syntax here. Get that back and go over that transform. So we're skipping non-public, skipping abstract generics. We find the option section. We collect some property info, namespace, get that little model. Then we'll use a thing called the additional text provider. The additional text provider is a way to read other files that are part of my application that are not code. I'm going to take all the files that end with options.schema with an ordinal ignore case compare, which again returns an incremental values provider. So Roslyn will watch these other files in my code base and say, oh, if one of these pops up, if this changed, we need to rerun this part. And then I run this through a parse schema text, which is a simple function that will go through my ini-like thing. You can make this as complex as you want, but it's an advantage to keep it simple, so because this will run whenever things change. And then we collect those. And then we combine our option types with our schema files and get that into one incremental values provider, left and right. So these are combined as they go along. And then we add some source, model type name, options binding, .g.cs. And then we have the emit class, which will generate code. So these are all just helper functions to generate the code. Not super interesting for this purpose. So here's my option bindings generator. It will find the section in the configuration. It will do some validation. If API key is null or white space, sure, we need that. It's not okay. If timeout seconds is default, then set it to 30, which was the value that we set as the default part. So if we go in here, oh. We'll open the schema. We'll say, actually, we want that to be 15, the timeout. And then it changes to 15, because I changed this option schema file. API key, it doesn't have to be required. We can just leave that out of there. Parts of my code changed again. Actually, we probably should make it required. There. There's my things. If I go in and say my app settings, I drop this one. I'll run my code. Again, exception, my API key is required. Oh, of course it is. Put that in there. So by using the But using the additional text provider, I can take other files, include them in my evaluation. They will be incrementally read. If they change, they will trigger a new one. The model will be updated. That part will be updated, and I can emit more code. We'll generate one file per type. So touch logging options, and only that part is generated. Touch payment options, only that part is regenerated. All right. We could extend this to do JSON, for instance. We do need to include some kind of JSON parser in our little parser text. Maybe we could build our own little JSON parsing. Parsing text is really easy, isn't it, Dylan? Yeah, he nods. So we listen for attribute, we listen for the class, figure out what do we want, and then we find the different schema files that go with it. All right, let's do one last one. Oh, wrong one. That's the one we want. Okay. So this one here, I have an order class. Oops. There we go. I have an order class. Super simple, has an identity, it has its status, it has a quantity, has a strongly typed ID, of course. And since any of you were in Jimmy's workshop this week, yeah, you learned you should never return the domain objects to outside your domain. So we create a DTO, which is our data transfer object that has some of the same properties. So I want my order class to be mapped to an order DTO. I could use AutoMapper for this, sure. Or I could use strongly typed generated code at compile time to do this more effectively and maybe with less harm. So I can do this with an attribute. Again, here I'll say map from type of order. So this class here should map from order. Cool. Find all the map from attributes. Make sure it's a type declaration syntax. It should be a class declaration syntax, so it has some generics in it here, type declaration. Or it could be a struct. Should have more than 0 attributes. Transform it, go through it, collect all the different properties, the destination properties, find the get the type that we want to convert from. Make sure we have the namespace and all the syntax, and we create a little model with the namespace, the destination type, the source type, destination props, source props, and wherever things are located in code. Emit one per destination, go through all of these, and then we'll just look at that first, and we'll look at something more interesting afterwards. Oh, my code failed compile. Property note, I get this red squiggly line here. Map 001, property note on destination type order DTO has no matching value. That's inconvenient. No matching readable property on source type order. So I've built in some rules here that says, well, if things don't match up, we want compile time checking for that. So we got an error here, you can click, go straight to it. Those are these things. So I can emit diagnostic messages during my run through the generator. These happen to be a diagnostic severity error, so they will crash my code. I can have warnings, or I can have info. These are a handy way if you want to emit data during your source generator run. Sort of like a console.log, just worse, because I can make errors. And there's a this part here. So here I've run a method where analyze. This is my method that just goes through these things. Are things missing? Can they be mapped? Such and such. And I will report a list of things that are missing or things that are incompatible. It will emit a list of diagnostics, which are these little things, diagnostic descriptors. And for each of the ones that are missing, report that diagnostic. And for each of the ones that are incompatible, report those diagnostics. If there are errors, we're going to stop generating code or skip generating code. We don't want to add more stuff to our crap. So for instance, we go to order DTO. We'll say, this is the one that's cool. Let's make that an int. Immediately, squiggly line. Cannot assign source order ID, type app order ID to destination order DTO, which is of type .id, which is of type int. So I immediately get errors in my code. This is a huge part of the falling into the pit of success, where I can say, okay, we're going to map this from this type, and my compiler will immediately let me know if there are things that are missing, things that are wrong, or things that aren't the way they're supposed to be. So I can go into my order class. Of course, I should have a public decimal price. No, that's not what I wanted. I want a public decimal note, because I missed that one. There we go. That will convert nicely into string, because it has a toString method, so that works for this compiler. So depending on how smart you make your little analyzer, you might not catch all the errors. Your generator will only be as smart as you are, so we'll say string. We need to make it a default value. There we go. What do we here? Source generators, map from generators, order DTO mapping, and it creates this. I also added in a little on-after-map function. So I can go in here and say, well, on aftermap, function in order there. You're complaining about what? This should be static, partial void on aftermap. The what? Oh, sorry. I'm putting it in the wrong class. That's right. I can make my own here. Public, static, partial, class, order DTO mapper. That's the one I want. Then I do it like that. Because this says you can make this partial method somewhere if you want. And I can make that here. And I get some rules for that. So I can have rules that will run after my mapping. Now if I try to build my project, finish building project annotations, finish building project app, succeeded, true, everything is great. Sweet. Again, there's some possibility for error here. What if they have only init properties? Maybe that won't work as well. Here I just set the things. There's lots of room for improvements. The analyzers will run in my code just as long as I keep adding my code. When I keep changing my code, the analyzers run. I can get squiggly lines. One important part here is let's go to the map from generator. And this part here is really important because that gives me the location of the code. So whenever I get I get parts, collect the parts, I also collect the location in my code, and that is the part that lets me say where, that is the part that lets me say where the location is. So I create a diagnostic, the Mr. property dialog, and the location of the code. So find my locations, get the first one, get it in source, and then get the location of it. So those are the things that enable me to collect the code, if I find an error, I can point the diagnostic and say, there's a diagnostic message, the error exists over here. That is the part that enables me to click this link, it puts the squiggly lines in place, everything is great. So my generated code is over here, again, just normal string concatenation, nothing more fancy to it. I have my model, which I try to keep as small as possible, because these models are the ones that are stored by Roslyn, cached by Roslyn. So you don't want to store the entire syntax node, because that's a bigger object. Just make your own little minimized model, which is immutable. You get new ones all the time. And where my attribute location is. This method here of generating these mappers will make that you have zero reflection on any hot paths codes. You get compile time safety. So any broken contracts will be broken on build, not in production. The generated code is pretty much self-readable. It is diffable if you want it. You can review it, make sure it's right. And all the changes are incremental, so it makes it really fast in a loop. There's nothing you need to run to generate this or anything like that. You don't have to run tests to make sure that your mappings are matched. Your compiler will fix this as you go. So those were 4 examples of how to use source generation. We use it for different things. We generate strongly typed identities. We do a little bit of mapping whenever we want to. But you can really use this for everything you want. There are a bunch of libraries that exist that do these things. There are libraries that source generate mappings. There are libraries that source generate strongly typed identifiers. That's cool. But the powerful thing about here is that you may have your own special use cases. You generate your own boilerplate for some reason. We have a bunch of database contexts that we want to do a bunch of stuff with or hook them up for registration. We just find all of those, generate a thing, here they go. We have a bunch of interfaces and a bunch of different domains that we want to register and run through at different points of time. So instead of using reflection to do this, we can just generate this at compile time. All these little edge cases, corner cases that are particular for us. So think about your own code base and say, I wish we didn't have to do this every time we do something. Or this thing is just this is inconvenient. Every time I do this, I have to do this. It's stressful. Okay, can we make a rule about this? Can we put this rule into our code? Can we enforce this rule and make sure nobody can forget it? If you ever had the thing where like, oh yeah, production's broken because Carl forgot to do this one thing. Well, maybe Carl shouldn't have to remember to do that thing. It isn't Carl's fault, it's the system's fault. We can make our systems better by making our systems, computers, do the hard manual work for us. If you have any questions, feel free to ping me on email or just Henriksen. I know you'll find me on the web there. I'll upload this code to this location shortly after this talk. And thank you for finding the room. Oh, and the staff wanted some help in cleaning up stuff, so there's a bunch of green notes over there. We just put them in the bowl on your way out. That would be really helpful for them. Oh, thank you. Hi.
Does this work the same for .NET Framework?
No.
Oh, so this is only .NET Core?
Yes, .NET Core. Need to upgrade, man.